Hey all, welcome to the today's tutorial. So today we will see what are the smart objects, and like smart objects are recently released feature. It is in Unreal Engine 5. So it is still in the beta mode or the experimental phase. It is not in the production mode, so it is also recommended not to use in the production ready environment. So like today we will see. So if any one of you have gone through the city sample map, so there were AIs who were interacting with the table, right? So it was very interesting, and I was actually curious, like how AI, like random AI, will come and sit, and they will go along. So let's start from here only. So there is a system called slot and subsystem of the like smart object subsystem. So what it will do, let's imagine some AI is here. The AI will query around its like it in the world. It will query like where are the smart objects if he is looking, and the subsystem will return the array of the smart object. He will choose some, like it is in the logic, like you can choose distance wise or the priority wise. It's on you. So let's imagine like the system write this object. So the AI will ask to provide him the handle. So handle is like the object, you can say, and he will ask if it is like there to occupy or not. If it is there, then he can use that. So today we will see the implementation. Okay, so it was the like just the intro. Okay, so let's begin. So how to start? So first, let me press F11. You have to activate some plugins which is already there. If which I think it will already be there. So the first thing, let's make sure that smart objects. Okay, it was not included. Just press yes. And next is AI behavior. So see, it is saying that is in beta. Just press yes, and I will restart it. Okay, so I am restarted my system. Let me come out. So I'm in the parent folder. I'll name it as the sub or the smart object tutorial, just to have the some cleanness. So first thing which we need to create, just go to the like blueprint, not the actor, sorry. Let me delete again. Go to the blueprint, go to all class, and search for the gameplay behavior. So in the gameplay behavior is the responsible, like what the actor will perform some action. So the main logic will be implemented here. So I will name it as BP underscore like attack or some gameplay statics. Okay, so gameplay behavior. Press yes. And second is you have to create the gameplay config. So it's same, just go to the blueprint class and gameplay config, no, gameplay behavior config. Okay, so this is the one, just select and bp underscore attack gameplay config. So these two are connected. Like in the config, we usually keep the reference of the gameplay behavior. So whenever we will, give the response, give the reference of the config, the behavior will always be there. So how we will connect these two? Just let me plug it in here. Okay, just see at the right, you have the details panel. Just drag it down, and we will select bp underscore attack gameplay behavior. That's we have to select and compile and save. So we have functions. Okay, so this is the config file. We don't need to create anything right here. Go to the behavior one. Let me put that here. Go to the functions and on triggered character. Let's do it here. So what action do you want to perform? Or if you have some particular type of avatar, or the character avatar is the character here, so we will cast to our class, and we can call some functions. So let's we don't have character any we I do have. So what I will do, I will use the same character. So this is the character which I will use for this testing. So like just let me copy paste it to my parent folder which I am using, smart object. Let me paste it here. Okay, just press yes. So I will like delete the whole bindings because it will be the AI. So AI control is there. Okay, so let's create a function or the event, custom event, perform attack. And we will do, for now what we will do, we will just like print the string I am attacking. Okay, just compile and save. So this is the character. So what we can do here, we can just cast to sin character, and we can, the function name was perform attack, so perform attack. So this is it. Okay, so and once we are done with the function, like once this is done, so we will call a function called and behavior. And behavior means that okay, now we are done. So we have to give the reference of the avatar. So we will just give the reference of the avatar. So it's the same character. Okay, now we will see how we will connect the like AI with these behaviors. So first thing, we need to create a data asset. So go to the miscellaneous data asset and we will search for smart object, object definition, select. So smart, I will just I always prefix my file name as m, and smart object definition, or rather I will call m attack smart object definition. So this is done. Okay, so here is the actual part, like how many slots will be there, you have to define it here, and what type of like what type of behavior definitions are there, so we have to define it here. So first I just want one slot. Slot is just the position, like it's just the reference, like transform you can say. So what are the like debug rotation, you can just have multiple slots and give the offset and the rotation, so it will be like that. And in the default behavior definition we mainly have two type of it. Just give me a second, let me open it. Okay, so first thing is I have created the definition smart object one. So this is one type. There is one more type which is not there right now, but we will because we are creating the gameplay behavior type, so we will select it. And in the config we have to select our config which we have created. So let me save and let me show you. So in the smart tutorial, see, so this is the config file which I have created, like which I have selected here. So we are done. So in any actor like which we will like make the smart object, but we have to give the reference. So there can be multiple type of smart objects in which we will have, like we can have different type of config files, correct? So this is one type. So let me save and let's see how we can create the actor, the smart object. So I will name it as smart object. I will go inside it and I will add the static mesh, or let me check whether I have something like something fancy to put on. Let me check. Okay, so I have chosen this mesh, and but this is not mandatory, just for the visual. So the main thing is like just you have to add the component. So smart object. So this object, sorry, this component is main responsible to make this actor as the smart object. If you will not add this component, the AI will not be able to see this actor as the smart component. Second thing is you have to apply the definition asset which we have created. So which we have named as m attack smart object definition. So and this file what it was doing, it does contain the information of slot. Just compile and save, and we are done with the actor. Like it's just like it was just to make this actor as the smart object. That's it. Okay. So the next thing is, okay, so let's create the behavior tree now, which AI will follow. Right now, this AI, which we have created, it is empty, right? Because we just have created a function, nothing else, correct? So let me create the behavior tree. So go to the artificial intelligence and behavior tree. So B tree attack. You save, and I will create the blackboard. So BB underscore attack. I will just connect these two, open it, choose the behavior tree and press yes. Oh sorry, I think I missed. Okay, okay, these two are connected now. If you will go check here, it is B attacking. Okay, these two are connected. So the behavior tree is the main place where the main logic runs of the AI is, correct? So we have to have the some task. So okay, so we will create the logic from the root. I will just I'm just using the basic functionality. From selector I will use the sequence. Okay, and I will just put some random weight. It's not okay. So here I will create two main tasks. One, I will search for the smart objects. So it will be my first task. So I will create one. So bt t underscore find object, and I will create one more task like btt underscore use object. So these two things will be there. So in the find object, so let's complete the behavior tree first. Just go to the task, and I will find, and it is the sequence node, so it will go from left to right. And in the task btt use object, so this thing we have to use. Okay, just save. So we are done with the like behavior tree, and we haven't created the main key yet. So let's create the key first. Just choose the smart object claim handle. So it's a like a smart object handle. Press yes. It just these two are the things only which we need. Okay, and okay, let's go to the task. Override a function. So we have to override a function. So receive execute AI. So as soon as the AI will receive command from here, from this node, so like what we will do, we will search from the smart object subsystem. So smart object subsystem and get or the find smart objects. Let me connect these two, and from the request I will just get a reference or copy. I'm taking the first element. You can query them out and you can write your own logic, and if it is correct, like I will just put a branch there. I'm just checking if it is, like if we have something or not. If we don't have, then I will like finish the execution with success of. Else what I will do, I will okay, so in the first, as soon as I will get something, I will send the claim command. Okay, okay, let me get smart object subsystem, and so just get the smart object, and I will okay, so I will send the claim command. So what exactly claim will do, it will check. So first let me connect this. So what I'm doing, I am finding the smart objects, and from that array it will give us the a smart objects array, and it will just pick the first one, and it will like we have it, and now we are actually checking if we can claim it or not. If we can claim it, then I will check if it is valid or not. So is valid. If it is, let me put a branch here. If it is true, then I will finish execution, execute, and it will be the success. So see, every command which have false, so if it is not, then I will again click to the finish execute as false. So let's reiterate through once again. So as soon as I will, like, the behavior tree will hit the find object, it will ask from the, sorry, it will ask the smart object subsystem to find the smart objects. Okay, first we have to make the request. So make smart query request. We need the query box and filter. Make smart object request filter. Just let me have some room here. Okay, and I will like get actor location, and to create the query box, what I will do, I will minus and plus. Okay, literal float. So how much big you want to have the box, so it will be of the 2000, and I will make the box. So make box min max, and I will connect it to the query box. Okay, so we have created the box, and let me, okay, for the behavior definition class we have to select what type of behavior we are looking for. So we as the previous one, when we were setting the smart object definition, so we have to like keep the same behavior class. Okay, so we have filters and everything is looking fine. Next thing, yes, so as soon as we are setting it true, we have to save this handle. Remember, like, we have created the key in the blackboard. Where is it? I think we created one key. I don't see it here. Okay, this is here. Let me copy its name, and what we will do, just go to the find objects and get the reference. Okay, get reference of the controller, because controller keep the reference of the blackboard. So get blackboard, and from blackboard we will save value as smart, set value as SO claim handle, just put it inside true, set it here, and right click literal name, just copy paste that name which we have set in the blackboard, and plug in it here. And what value do you want to save? So this, the claim handle, we have to put it here and compile and save. So everything looks good at this side. So as soon as we are setting the finish execution true, so it means that we have, like, blackboard have the value of a smart object handle. Now we will go to the another task which we called as use object. Let me again override the same function, receive execute AI. So the first thing which we will do, we will just get the reference of the blackboard, because we want to get that value. So get value as smart SO claim handle. Let me literal f name, and paste the name. Just make sure that this value which you are putting it is correct, and we will use claimed smart object. So this is the main function. So what it will uh, okay, let me like put the controller on, and we have connected the claim handle. Compile and save. So what it is actually saying, to like whatever function is there, like whatever function is there inside the object definition, smart object definition, and we have kept the reference of the gameplay config, and gameplay config has the reference of the gameplay behavior, so it will run this function mainly. Okay, so again, use object. So as soon as we are on finish, we will finish execute, and with the proper success, just compile and save. Okay, everything looks good here, good here too. Okay, yep. So once again, if we want to, like go through, so the main thing is there, the main logic is in the gameplay behavior which we created from the blueprint. Next, the reference of the gameplay behavior is kept in the gameplay config, so we have created the config class. Now the binding of these two will go inside the where is it, see, no, nope, yeah, here. So this smart object definition, so in the smart object definition, we will actually set how many slots should be there, what will be the offset rotation and something, and the color of the debugs and all. Here you have to select the gameplay config, and it will all be connected. So we are here, and the object, like the main actor which we want to like call it as the smart object or the smart actor, we will add this component, and in the component we will select the definition. That's it, and it is all good to go. Next thing, we will test our behavior like in here. So what we will do, let me put this AI here, and as for AI to run, we need to add a nav mesh bound volume. So let me press G, let me scale it a little. Or we can scale a little up so it will look good. Nope, wrong one. And okay, and for the smart object, let me put that smart object here. Okay, okay, so let me press P, just so we can see the navigation. We have like make the Z very high and it is low. Okay, just press P and G again, and let me simulate the game. Let's see. Okay, our AI is here. Let's see if it is moving or not. No, it is not. So let's go to the behavior tree just to check if everything running fine. Let me select the object. Oh, correct, correct, correct. So the issue with the correct implementation is we haven't set the behavior trees yet in the AI. So let's go to the AI. What we will do, like on possess, we have a function called on possess. So possess, yep. So the in like as soon as so what the engine does, if you have put some AIs or the character there, if it is not the player controlled character, then AI controller will auto possess it. So when the possess will happen, it will trigger this event possess. So and with the we will cast it to AI controller, and we will run the behavior tree. We will select the behavior tree, compile and save. Let's check. Let's hope it will work this time. Nope. Let's go to the behavior tree again. Okay, it is go inside the, it is going, okay, but it is not working as expected. Let's see why. First thing, we can actually turn it to 0, or we can just delete it. Save, go, let me play that again. BT attack. Okay, so find object, let me select the pawn. Okay, so this is false. Okay. Okay, so the main issue which it was returning true, because that object which he's finding inside the periphery of this, which we have put 2000, and we have put the object really far. So what we can actually do, either we can increase this volume, like maybe like 50,000. It will be too high, but it should work. Let's play. Now our object is going, and he's attacking, he's printing the attack button. uh okay, so this was it for today. Okay, just for like, if we want to continue a little, we can actually perform some tasks, like we can like ask this mesh to perform some action, like play animation, and we will play the animation of attack. Maybe no, it, no, idle, for loop maybe. Okay, and play once, two once. Okay, compile and let's play. Now character is coming, and see, he's playing that animation. He's still sleeping. Okay, so this was it for today. If you like the tutorial, please like and subscribe, and let me know like in like what should be the topic for the next tutorial, and I will make it for you. Okay, take care. Bye bye.